I decided to speak about a very recent paper we have published on a very well-known and important result by Gliwenko, published in 1921. Oh my God. I'll begin with some historical remarks. I will very quickly present a first paper by Gliwenko, published in 1928, and then I'll go to the main paper of the talk, the paper published in 1929. I will speak a little about some known historical translations, about some research project we have developed during several years concerning translations between logics, and I will call attention to two special types of translations. We have studied conservative and contextual translations, and then I will revisit Gliwenko's interpretation, and I will show that Gliwenko's function is in fact a conservative and a contextual translation. But I will finish with some concluding remarks. Valery Gliwenko was a Ukrainian Soviet mathematician. He was one of several Soviet logicians who, like Kolmogorov, worked on the intersection of algebraic logic and probability theory, foundation of mathematics, real analysis, and mathematical statistics. He taught at Moscow Industrial Pedagogical Institute until his death at age 43. He passed away very young. Most of Gliwenko's work was published in French. There are a few fundamental theorems bearing his name. This presentation is about Gliwenko's interpretation of classical logic into intuitionistic logic. Gliwenko's 1929 fundamental paper was presented at the Académie Royale de Belgique par Monsieur de Dondé. To the right, we have the first page of the volume. It was not easy for me to find this original publication. I tried to obtain it from Russia, from several universities, but I couldn't. A previous postdoc of mine, Peter Verde, could find this number of the Bulletin de la classe des sciences de l'Académie Royale de Belgique at one university in Belgium, but it was not easy. And then he could take a copy and send to me. I had several quotations about the paper, but when I decided to study directly the paper, it was very difficult to find a copy of it. The paper, the title of the paper is Sur quelques points de la logique de Monsieur Brouwer, about some points of the logic of Monsieur Brouwer. It was published in 1929, as I have said. Here is the facsimile of the paper. And in this paper, the paper of 1929, used a previous paper published by Gliwenko by the same Bulletin de la classe des sciences de l'Académie royale de Belgique, a previous paper published in 1928. In this paper of 1928, it was proved by Gliwenko a remark Brouwer theorem at that time. He proved that in Brouwerian logic, we have the falsity of the principle of the third excluded. And so in this paper, Gliwenko proved that the double negation of the principle of the third excluded is valid in the Brouwerian logic. Okay. In the paper of 1928, Gliwenko presented an axiomatic, let's see, in 1928, the non-axiomatic presented by Hating was published in 1930. He presented a proposal of an axiomatic for the logic of Monsieur Brouwer. He presented this axiomatic with 9 axioms presented here, the 9 axioms. Let's see, we have P implies P, P and Q implies P, P and Q implies Q, transitivity, P implies P or Q, Q implies P or Q, and here we have the P implies R implies that if Q implies R, then Q or Q implies R, and here we have the reduction of absurd.
Sorry, Itala, it's probably a typo in action number 2.
Sorry?
It's typo in action number 2. It shouldn't be in the antecedent, not P implies Q, but
yes.
P implies P, but P implies Q.
P implies Q. It's okay, thank you. And he proved in the paper, in page like noted here, he proved 4 results for the system. The double negation of not P or P, P implies not P, P implies Q implies not P, and that the triple negation of P implies the negation of P. And so he proved these results for the system in 1928. And in the paper, he proved that if the falsity of a certain proposition is a consequence of the principle of the third excluded in classical logic, then the falsity of this proposition also occurs in the Brouwerian logic. So if you have that in classical logic, not P or P implies not Q, then in his Brouwerian logic, we have not Q. Okay. In his paper of 1929, I show in my conclusions that he was having a correspondence with Hating. There are some letters from Gliwenko to Hating and from Hating to Gliwenko. And Hating suggested him that his axiomatic for the Brouwerian logic was not sufficient, was not good enough. And Hating suggested to Gliwenko to add more axioms. And Gliwenko added to his 9 axioms 4 axioms, the axioms A, B, C, and D. And this was published in the paper of 1929, a new axiomatics. And in the paper, he showed that if he add, I'm having a problem because I'm not having the slide, how to present the slides. if he showed that if to his 9 plus 4 axioms, if he add axiom 1 or axiom 2, the principle of the third excluded, he would obtain classical logic that he called logique classique des propositions. And so in the paper of 1929, he introduced an axiomatic for Brouwer's logic, and he showed that it was sufficient to add only one axiom in order to obtain classical logic. Classical logic according to the system introduced by Hilbert and Ackermann in their paper of 1928, 1 year before. Okay, in this paper, he proved a very important theorem that was used by several other authors after him. He proved that if a certain expression of the logic of propositions is proved in classical logic, if you have alpha proved in classical logic, then the falsity of the falsity, that is the double negation of this expression, is provable in Brouwerian logic. This result is very well known as the Gliwenko's interpretation from classical logic into intuitionistic logic. He proved that if we have a theorem in classical logic, then the double negation of the theorem is a theorem in Brouwerian logic. Okay, as a corollary, it is easy to show that if the falsity of a certain expression of the logic of propositions is provable in classical logic, then this formula, this falsity is also provable in Brouwerian logic. This is also proved in his paper. An observation, this is not in the proof, but it is easy to see that the converse of the theorem also holds. If we have the double negation of a formula proved in the Brouwerian logic, then the proposition is proved in classical logic. And so we have that, in fact, Gliwenko theorem is an equivalence, is an interpretation reversible from classical logic into intuitionistic logic. These things are shown in the paper. Another simple, very simple corollary is that if classical propositional calculus is inconsistent, this classical propositional calculus is inconsistent only if intuitionistic propositional calculus is inconsistent. Okay, but Gliwenko's interpretation was mentioned by several other authors during the 1930 decade. But the first known translation involving classical logic and intuitionistic logic was presented by Kolmogorov in 1925. After Gliwenko's papers, Gödel and Gensten independently also introduced two other interpretations from classical logic into intuitionistic logic. Their translations were developed in order to show the relative consistency of classical logic with respect to intuitionistic logic. I will speak a little about Kolmogorov interpretation because it is very beautiful, and at the end of my talk, I would like to discuss with you some questions. The first known translation involving classical logic and intuitionistic logic was presented by Kolmogorov in a very, very beautiful paper in 1925. After Gliwenko's paper, Gödel and Gensten independently introduced it. I have spoken about this. Kolmogorov anticipates in his paper not only Hating's formalization of intuitionistic logic, but also results on the translatability of classical mathematics into intuitionistic mathematics. This paper is very beautiful. It was published in Russian in 25, but it appeared in English only in 77 in the famous book by Hayenot, From Frege to Gödel, a source book in mathematical logic. The aim of Kolmogorov is to explain why, I'm quoting, the illegitimate use of the principle of excluded middle in the domain of transfinite arguments has not led to contradictions. Kolmogorov, in his paper, he has introduced two formal systems. A system he calls B, the intuitionistic Brauerian calculus, and the system he calls H, the classical propositional Hilbertian calculus. The system B by Kolmogorov has 5 axioms. Let's recall that Gliwenko presented 13 axioms. 5 axioms, modus ponens and substitution rule. Let's see that axiom K5 is the principle of contradiction. And also, Kolmogorov, an observation. This system B, introduced by Kolmogorov in 25, differs from Hating's system of 1930 only by one axiom. Hating's system is Kolmogorov's system with one more axiom. From phi and not phi, we deduce psi. But I have an important observation. Kolmogorov, in his paper, he claims that this proposition, this formula, would not be acceptable as a basic principle for a Brauerian logic. He claimed that it would not be acceptable according to Brauer's philosophical principles. Kolmogorov's paper, Kolmogorov's system is in fact the well-known, nowadays known as Johansson minimal calculus. So the paper introduced by Johansson in 1936 is exactly the system introduced by Kolmogorov in 1925. And so I used to say the minimal calculus, the Kolmogorov-Johansson minimal calculus, because in fact it was introduced by Kolmogorov. And according to Kolmogorov's discussion, his system is also a kind of a paraconsistent system, lato sensu, broad sense. Because from a contradiction, we does not have any formula whatsoever, but only negated formula. And so the principle ex falso sequitur quod libet is not valid in general in Kolmogorov's Brauerian logic. The special logic of judgments obtained from the system B, he called his system H, the classical logic, as a special logic of judgment, adding to his 5 axioms only one axiom. From the double negation of phi, we deduce phi. It is proved that H is equivalent to Hilbert's classical propositional calculus, the paper published by Hilbert in 1923. Given both systems, Kolmogorov defines inductively a function, I'm calling K, associating to every formula alpha of H, a formula alpha K of B by adding a double negation in front of every subformula of alpha. And Kolmogorov proves that given a set of axioms A, if from A we deduce in H alpha, then from the associated formulas of alpha according to his interpretation. In the system B, we deduce alpha K, the interpretation of alpha. And he suggests that a similar result can be extended to quantificational systems and in general to all known mathematics, anticipating Gödel's and Gensen's results on the relative consistency of classical arithmetic with respect to intuitionistic arithmetic. Kolmogorov was very young, 22 years old, and he anticipated the relative consistency of classical arithmetic with respect to intuitionistic arithmetic in this paper. There are two other interpretations from classical logic into intuitionistic logic introduced by Gödel. In this paper, I'm not putting detail, in a paper published in 1933, so 8 years after Kolmogorov's paper, and also a paper by Gensen, published too in 1936. Gödel doesn't mention Kolmogorov paper, but he mentions Gliwenko. There are some very recent extensions of Gliwenko's interpretation, Gliwenko's. I'm mentioning here some papers by Signoli to Haynes. They are papers relative to substructural logics, where the interpretation given by Gliwenko is extended. There are papers by Signoli to Haynes, 2003, 2004, 2006, by Hiroakira Ono and Galatos, several papers extending Gliwenko's results. For instance, a paper published in 2012 by Ferreira Oliva, by Hiroakira Ono in 2009. Okay, but in spite of Kolmogorov, Gliwenko, Gödel, and Gensen dealing with interrelations between the studied systems, they are not interested in the meaning of the concept of translation between logics in general. Since then, interpretations between logics have been used to different purposes. Pravit and Malminas, in a paper of 1968, surveyed these historical papers I've mentioned, and is the first paper in which a general definition for the concept of translation between logical systems is introduced. In a paper published in 1999 with Da Silva and Sete, we explicitly interested in the study of interrelations between logic systems in general. We have proposed a general definition for the concept of translation between logics in order to single out what seems to be, in fact, the essential feature of a logical translation. Logic, for us, are characterized as pairs constituted by a set and a consequence operator, and translations between logics are defined as maps preserving consequence relations. This paper was published by Lecture Notes in Pure Mathematics in 1999. We consider a logic as a pair constituted by a set with a consequence, a Tarskian consequence operator, but we can deal with non-Tarskian consequence operators, and for instance, with non-monotonic logics and with inductive logics, and with abductive logics too. But here I'm dealing with deductive logics. Okay, or definition for a function being a translation. If A and B are formal languages with associated syntactical consequence relations, CA and CB, a translation from A into B is a function such that if from gamma we deduce alpha in the first system according to the consequence operator C alpha, then from the translation of the formulas of gamma, we deduce according to CB the translation of alpha. So for us, a translation is a function that preserves consequence relation. An initial treatment of a theory of translations between logics is presented in that paper. And we have several other papers related to this subject. And an important subclass of translations, the conservative translations, was also investigated by us. And a conservative translation is a translation in which the reverse of our definition also works. So we have a translation when, if from gamma we deduce alpha in the first system, this happens if and only if from the translation of the formulas of gamma, we deduce the translation of alpha. And so a translation we have only from the left side, we go to the right, and a translation is conservative if also if the if and only if works. Okay, we have several papers on the subject. I will mention one general, more recent. Kolmogorov's and Jensen's interpretations are conservative translations from classical into intuitionistic logic. But Gödel's interpretation of 1933 is not a translation in our sense because it doesn't preserve derivability, it only preserves theoremhood. We have introduced several conservative translations involving classical logic, intuitionistic logic, modal logic, Lukashevich and post-human valued logics, several paraconsistent logics and predicate logics, and have obtained with syntactic results using syntactic results, algebraic semantics, and matrix semantics. According to, there were some problems relative to our definition of conservative translations. And then we presented another definition, restricting our definition of translation. We have introduced the concept of contextual translation. Contextual translations in a paper with Carnielli and Coniglio, published in 2009, contextual translations are mappings between languages, preserving certain meta properties of the source logics that are defined in the source logics in the target logics that are defined in a formal first order meta language. But after having defined this new concept, we had supposed that it would be an independent concept concerning conservative translations. But we have shown that these concepts are not independent. We have found examples in the class of translations between logics. We have found examples of contextual translations that are not conservative translations that are not conservative, and translations that are in the intersection that are conservative and contextual. I'm explaining this because I will return to Gliwenko interpretation. Okay, a PhD student of mine extended the concepts of conservative translation and contextual translation to a new context of abstract contextual translations. And we have shown that if you consider the class of logics with translations between them, we have an intermediate concept between translation and conservative and contextual translation. These are the abstract contextual translation. I'm not giving details here. But what's important, what have we shown? We have the class of logics with translations. We have the abstract contextual translations. We have, among the abstract contextual translations, some translations that are conservative and some translations that are contextual. We have the contextual conservative translations as very special cases of translations between logics. And we have some other kinds specific of translations, but among the contextual conservative translations are exactly the isomorphic, the translations which express the isomorphism between the logics, special cases of conservative and contextual translations. The isomorphic translations here. Okay, we can deal also with non-monotonic logics, which include the Taskian logics inside. Let's return to Gliwenko. Let's recall. Gliwenko introduced the function from classical logic into Brauerian logic, such that the image of a formula is the double negation of the formula. And he proved that if alpha is a theorem in classical logic, the double negation of the formula is also a theorem in Brauerian logic. The question we have tried to ask, is Gliwenko's function a translation according to our sense? Is it a conservative translation? Is it a contextual translation? Okay, we have shown very simply that Gliwenko's function is a translation because it preserves derivability, not only theoremhood. And by using algebraic semantics, it was not so trivial. We have proved that Gliwenko's function is also a conservative translation. And so it preserves derivability and also conserves derivability. So Gliwenko's function, we have proved that it is a conservative translation from classical logic into intuitionistic propositional logic. It was not difficult. It was easy to show that Gliwenko's function is also a contextual translation because it preserves meta rules of the source logic. We have only to show that modus ponens is preserved from classical logic into the translated formulas in the intuitionistic logic. And so we have proved that Gliwenko's interpretation is a translation according to our general definition. It is conservative and it is contextual. And so it is also abstract, an abstract contextual translation. Let's go. It is also an abstract contextual translation. It's a translation because from gamma, if from gamma we deduce alpha, from the double negation of the formulas of gamma, we deduce the double negation of alpha. It is conservative because we have the reverse of the first sentence. It is contextual because it expresses it preserves the meta rules, and it is an abstract contextual translation because all translations which are conservative and which are contextual are also abstract contextual translation. Okay, Gliwenko's original result remains of interest. It has been really applied in many contexts. It was breakthrough at the time, introducing new concepts. We could say that, but recall that a much stronger paper was published before him by Kolmogorov in 1925. This Gliwenko's result can be requested in order to relate logics other than classical logic and intuitionistic propositional logic, such as logics intermediate between this logic and predicate calculi. From our general theory of translations, between logics, Gliwenko's function, Gliwenko's interpretation is an abstract contextual translation, a conservative translation, and also contextual translation. But my question, after having studied again his paper and the new results related to his paper, I didn't understand why didn't Gliwenko mention Kolmogorov 1925 paper in his papers of 1928 and 1929. In spite of being a mathematician and living in Moscow, didn't Gliwenko know Kolmogorov's paper? Didn't Gliwenko know Kolmogorov, the mathematician, the young mathematician? Okay, after trying to know this question, to understand, I found a paper by Trulstra, published in 1999 on the early history of intuitionistic logic. It was presented in an event in dedicated to Hating, to Arend Hating, and published in the Mathematical Logic Proceedings of the Summer School and Conference on Mathematical Logic, honorably dedicated to the 90th anniversary of Hating. I found this paper by Trulstra, and in this paper, Trulstra describes the early history of intuitionistic logic, of its formalization, and the genesis of the so-called Brouwer-Hating-Kolmogorov interpretation. And at the end of the paper, some source material is presented. In particular, letters from Bernays, Gliwenko, and Kolmogorov to Hating. And then I decided to read the letters to understand if Gliwenko knew Kolmogorov paper, if Hating knew Kolmogorov paper. And surprisingly, they knew both, but they never mentioned Kolmogorov's paper. I found letters from Gliwenko to Hating, some letters sent in 1928, when he was finishing his paper published in 1929. There are 5 letters from Gliwenko to Hating. And there is also a letter from Gliwenko to Hating sent in 1933. The letters from 1928 sent by Gliwenko to Hating document the discovery of the nowadays known as Gliwenko theorem. In July 1908, Gliwenko claims, let's see if I can put a little, yes. Gliwenko claims that in the letter, the double negation of double negation P implies P is not provable, might have been proved by him by using an interpretation in a particular matrix with through values. In October, Gliwenko reports his theorem to Hating, his theorem published in 1929. In October, 30 October, he comments that he intends to publish his result in the Bulletin de l'Académie Royale de Belgique, well understood if Hating's work that is going to appear in the Mathematical Annalen contient déjà ces résultats. So Gliwenko was claiming that he intended to publish his paper, but he wanted to know if Hating was publishing the same result in his famous paper published in 1930. In November, Gliwenko writes again to Hating, telling that he had decided to publish his result independently of Hating's paper. There is also a letter written in 1933 in which Gliwenko discusses Komogorov's calculus of problems interpretation. Its conceptions is very interesting, says Gliwenko, and mentions the possibility of taking falsehood instead of negative as primitive. In his letter of 13 October 1928, Gliwenko writes, dans les recueils mathématiques de Moscow, Kolmogorov, one of the, may I speak French or one of the most creative and good Russian mathematics published a paper called Sur les principes des tertium non datur in Russian, where he proposed an axiomatic for the intuitionistic logic of propositions. There, he rejects not only the principle of the third excluded, but also the principle from not P, we deduce Q implies P. So he has written to Hating. He knew the paper published by Kolmogorov. In his third letter in German, Kolmogorov wrote 3 letters to Hating. In his third letter in German and undated, Kolmogorov mentions to Hating his anticipation of the results of Gödel, published in 1933 in his paper of 1925. So Gliwenko knew Kolmogorov's paper. Hating also knew Kolmogorov's paper because Kolmogorov had written to Hating, claiming that he had anticipated Gödel's result, published in 1933. And so I continue trying to understand why didn't Gliwenko and Hating didn't mention Kolmogorov so beautiful and important paper, and let's see, more complete than the paper published by the authors who followed him. And it's interesting because when Gliwenko died, it was Kolmogorov who wrote his obituary in Russian in 1941. There is a recent paper published with a survey on our general results concerning translations between logics. And this paper about Gliwenko has very recently be published. Here with a co-author, Evandro Luis Gomes, remarks on an theorem of Monsieur Glivenko with all the proofs and detailed results. And many thanks.